Okay, in this problem we're going to evaluate the limit if it exists. This is the limit as h goes to 0, and what we see is there is a radical in this expression. It's radical 9 plus h minus 3 divided by h. What we're going to use is the formula a minus b times a plus b equals a squared minus b squared. So how are we going to use that here? Well, in the numerator, we have a radical minus 3. What I'm going to do is I'm going to multiply that. And what I'm going to multiply that by is what some people would call the conjugate. So I have a radical minus 3. I'm going to multiply it by a radical plus 3. I'm going to maybe pick a different color. A radical plus 3. Now, if I do that, okay, first of all, so I need to do the denominator over here also. So, okay, now, if I'm going to multiply the numerator by radical 9 plus h plus 3, I should do the same for the denominator. And by doing so, it's like I'm multiplying by 1. Okay, what's that going to do? In the numerator, this is like a minus b times a plus b. The denominator, I don't want to multiply that out. Why not? Because the h is actually what I want to cancel. See, if I try to directly substitute h as 0, that gives me division by 0. I don't want that. I want to cancel out that h. So I'm not going to multiply that h through. All right, I'm going to hold off on that, even if I want to or feel like doing that. I'm going to stop my impulse to multiply the h through in the denominator. I'm going to focus on the numerator, where I have radical 9 plus h squared minus 3 squared. I'm a little concerned that this color is not bright enough. Maybe I'll try to make that a little brighter. Pick a different one. There we go. Okay, so I have the first term, or a minus b times a plus b, so that makes a squared minus b squared. That's what I'm looking at there. And now I'll write down the denominator where I don't multiply anything out. I just write that down. Now let's see what's going on. Parentheses are important, of course. Okay, the first term squared, well, what does that give? I have a radical and it's squared, so the radical and the square cancel each other. And then I have minus 3 squared, which is minus 9. And here we go. All right, now we see there's some cancellation right here. The 9s cancel out, so that's some cancellation. And let's see what that gives then. Well, I'll write it down again. I'll have h divided by h radical 9 plus h plus 3. Now I'm going to cancel more. The h's cancel. When they cancel, in the numerator, what's left over is 1. So that gives limit 1 divided by radical 9 plus h plus 3, h approaches 0. This gives 1 over square root of 9 plus 0 plus 3. So once the h is canceled out, that allows me to directly substitute h as 0. See, h as 0 was giving 0 in the denominator. And also notice, throughout this whole process, I am writing down limit. I write limit, limit each time. And each time equals limit, limit. I don't drop that. I'm writing limit the whole time. But then when I plug in h is 0, I don't write limit anymore because now it's a number. There's no h there anymore. And now I would like to be able to do this without making a mistake at the very end. One of my things that I sometimes do at the very end, I sometimes make a mistake because I rush it. I don't want to rush. So that looks like it's 1 over 3 plus 3, which is 1/6. There's an exercise, an example in the book that has the same answer. It seems like it's a really similar problem now that I think of it. What would happen if I highlight it like that? Okay, I sort of use a lot of space there. The disadvantage is you don't really get to see the problem that easily all at once, but there we go. So that's the whole thing all in one screen. And let's see, this is from section 2.3, number 21, Stewart Calculus, 8th edition, early transcendental. All right, that's all.